Hello, my good students, and welcome. Today, I want to teach you about a chemical that is sulfuric 6 acid. As you can see the formula there, yes, we say sulfuric 6 acid is a dibasic acid, meaning it has two replaceable hydrogens, as you can see in the formula there. So that is the formula. Maybe the first thing we talk about occurrence. How does sulfuric 6 acid occur? It occur mainly as a mineral acid. You ask yourself, what are these mineral acids? Mineral acids are acids that we can synthesize in the laboratory. We can simply prepare them by mixing chemicals. Other examples, apart from sulfuric acid, we have the nitric 5 acid, the hydrochloric acid, the phosphoric acid. Those are examples of the mineral acids we have. Next, a very, very important process. Remember in one of the videos I posted previously, I told you one way to revise chemistry is to approach it from industrial industrial processes and contact process. The industrial manufacture of sulfuric acid process, it's very important. Now, we start by asking ourselves, what raw materials do we need? I need sulfur, and mainly this one I can obtain it from the Frach process. I can also get it from some metal sulfides, like some metal ores, like galena, that's lead 2 sulfide. I can get it from zinc blendeth, that is zinc sulfide. I can also have it from copper pyrite. The aim is just to have sulfur that will help me for the next stage. Remember, even iron pyrites, very important. Another raw material, oxygen. Mainly we talk about it, we say air. Like, remember the KCOC 2021, the question was, why do we prefer air instead of oxygen? So instead of going ahead to simply to do what you call purification of air to get oxygen, you can use air directly. So you also need water. So those are the three raw materials. For water, you need reliable water sources, be it rivers, lakes, etc., that can help you get enough of these. So these three are the raw materials. Going ahead, I now need to take you through the process, the contact process itself, and we see what exactly happens. So contact process, 6 main stages or compartments that we need to be very conversant with. Stage 1, production of sulfur 4 oxide, that is in the roaster. 2, purification of the sulfur 4 oxide and air. That one is done in the purifier or in the dryers. The heating of sulfur 4 oxide in air in the heat exchanger. Then we convert, the next step, conversion of sulfur 4 oxide to sulfur 6 oxide in the catalytic chamber. Then we have the next step in the absorption chamber where we convert sulfur 6 oxide to oleum. Then go ahead, we have the dilution chamber where now we dilute the oleum to get sulfuric 6 acid. And this is all I'm going to take you through, the 6 steps: the roaster, the purifier or the dryer, the heat exchanger, the catalytic chamber, the absorption chamber, and then the dilution chamber. We start with the first one. Here in step number 1, you can do it in a furnace, a burner, or a roaster. The aim is to produce sulfur 4 oxide. And you can see the chemical equation. We can burn sulfur. Yes, we burn sulfur in oxygen. We get sulfur 4 oxide directly. The chemical equation is as I've given there. And that first step is the most convenient. Because generally it will have minimal of impurities. Then we can burn metal sulfide. The chemical equation, as you can see there, the aim is just to get sulfur 4 oxide gas. Moving on, step number 2, the purification of sulfur 4 oxide. This one is done in the purifier. You can also do it in a dryer because we need to remove moisture as well. So you can see that dust particles and arsenic 4 oxides, those are the main impurities, because that one you can easily be asked. The question that you'll be asked, how do we remove these impurities? By electrostatic precipitation, a method called electrostatic precipitation. Another question, why purify the gases? That is it. Impurities will poison the catalyst. Otherwise, they will cover the catalyst, make it inefficient. Remember, catalysts work by a desorbent. The surface area is very important. And if the surface area is very important, it should not be covered by any impurities. So removing them help to prevent what we call poisoning of the catalyst. The dryer basically removes the moisture, and we can use concentrated sulfuric 6 acid to dry. Okay, we go on to step number 3, the preheating of sulfur 6 oxide and air in the heat exchanger. The temperature we apply there, 450, yes, 450 degrees Celsius. And you note that at a very low temperature, there will be very minimal yield of sulfur 4 oxide. So we need to work at a bit higher temperature. At the same time, high pressure will be too expensive to maintain, because those are the conditions that will favor higher production of sulfur 4 oxide. So what exactly do? We choose optimum conditions. There must be optimum temperature and of course the optimum pressure. And the optimum pressure and temperature, as you can see, pressure of 450 degrees Celsius and pressure of 2 to 3 atmosphere. Those are the two conditions that will favor the maximum yield with low cost of production, because this is an industrial process. So we must ensure we are minimizing on the cost of production. Going on, conversion of now the sulfur 4 oxide to sulfur 6 oxide. This will happen in the catalytic chamber. There must be a catalyst. Which catalyst do we prefer or are used for this process? Vanadium 5 oxide, otherwise called vanadium pentoxide, and platinum. Good. Vanadium 5 oxide is preferred. Another question that can easily be asked: why do we prefer vanadium 5 oxide? One, it is cheaper, less expensive than platinum. Again, it is not easily poisoned. It is not prone to poisoning or by the impurities. If you want to argue with the platinum, the opposite. Why is platinum not preferred? Very expensive. You can also talk of it being easily poisoned by the catalyst, by the impurities, sorry for that. Good. Then we have the hot sulfur 4 oxide being passed over the catalyst, and the sulfur 4 oxide react with oxygen, and 98% conversion, you get sulfur 6 oxide. Good. The chemical reaction for that, as you can see there, the chemical reaction, it's well given. We go to the next step, or rather we go to this question. This question was there in KCSE 2021 paper 2, and they were asking, why is this process called contact? That is the answer. The sulfur 4 oxide react with oxygen in contact with the catalyst, be it platinum or the other one, the vanadium 5 oxide. When the heat exchanger has two purposes: it can heat, it can cool. So why do we need to reabsorb the heat? So that can be used again. So the cooling of sulfur 4 oxide from the catalytic chamber goes back to the heat exchanger, where it is cooled, and then the heat is used back into the heat exchanger. The cooling is to make the process more economical. And that question was there even in KCSE 2021. Why the heat? Why do we absorb the heat or something like that? Good. We go to the next step. Now we need to convert sulfur 6 oxide to oleum. We do not dissolve sulfur 6 oxide directly in water. Another question you need to know why. Good. Remember, the sulfur 6 oxide is an anhydride of sulfuric acid, a non-metal oxide that can be dissolved in water to get the acid. The sulfur 6 oxide dissolved in concentrated sulfuric acid, not in water, get that, to obtain we call it the spirosulfuric acid, or the fuming sulfuric acid, oleum. That you can see the formula there. You can see the formula there. The chemical reaction for what is happening is as you can see there. That question I've just asked, why sulfur 6 oxide is not dissolved directly in water. That one, as a student, as an a candidate, you must know. That is it. The process is highly exothermic, and this makes this mixture, the acidic mixture, to boil. or rather to fume, and acidic mist is formed, which is not very friendly for a human being. The very last step, dilution of oleum. Now we need to add water carefully, calculated. This is calculated amount of water added to the oleum, and then it is diluted to 98% sulfuric 6 acid. The chemical reaction for that, as you can see there. Maybe you can practice writing chemical equation. Then the acid is stored, ready for sale. Good. Maybe in Kenya you can get to know where exactly is the contact process located. We have two companies in Thika, among others, of course, that maybe you can organize a student trip, academic trip to Thika, KEL Chemical Limited, Orbit Chemical Limited, both of them in Thika town in Kenya. That is just some 30 km from Nairobi, the city of Kenya. Good. Environmental effect of contact process. Sulfur 6 oxide, sulfur 4 oxide, they are pollutants. So when they escape into the air, as you can see, they can cause acid rain and so forth. So to prevent this gas from escaping, one, we can recycle them back into the heat exchanger to be reused. We can do a method called scrubbing. We attach the chimneys with calcium hydroxide or other chemicals that can react with the gases. And of course, like with calcium hydroxide, if it reacts with the gases, it forms a harmless calcium sulfide, which is a salt that can be removed and be used elsewhere. Chemical reaction for that, calcium hydroxide reacting with sulfur 4 oxide, you can. And maybe next is a flow chart. Good, there it is. You can see there the burner, that is the first stage of the roaster, where sulfur and air are burnt. Then sulfur 4 oxide and air comes out. More air is added, cleaning and drying. Then sulfur 4 oxide comes out again with the air, taken to a heat exchanger. Remember the heat there, 450 degrees Celsius. Then a pressure of 2 to 3 atmosphere. Then taken to a catalytic chamber where exactly the reaction between sulfur 4 oxide and oxygen takes place. Hot sulfur 6 oxide comes out, taken back to the heat exchanger for absorbing of the heat. Then out comes the what we call now cold sulfur 6 oxide, taken to absorption chamber where you add sulfuric acid concentrated. Oleum comes out, then diluted to get sulfuric acid. That is just the process. The process itself, you can look at it well summarized. And physical properties of sulfuric 6 acid when it is concentrated. It's a colorless oily liquid, very dense, less volatile. It cannot easily evaporate. It has a high density, 1.84 grams per cubic centimeters. It's a very dense liquid, you can tell. Melts at 10 degrees Celsius and boils at 338. It is highly corrosive when concentrated. It is very soluble in water, and the solubility is highly exothermic. Caution that you're always given: never add water into the acid. Actually, you dilute by adding the acid into the water, not the other way around. In a very controlled amount. You don't add too much of the acid into the water. Otherwise, never add water into the acid. The chemical is highly hygroscopic. Good. This acid has no effect when it is concentrated, no effect on blue or red litmus paper because it has no free hydrogen ions. It is molecular when it's concentrated. It's a non-electrolyte when it is in concentrated state. Highly hygroscopic, and for that case it is a good drying agent for gases. When you're preparing gases, concentrated sulfuric acid is a good drying agent. Moving on, some uses of sulfuric 6 acid. It can be used to make dyes and paints, can be used to process some metals, yes, be it etching metals, processing metals, etc. It can be used to make the lead acid accumulator, the car battery. It can be used to manufacture drugs, plastic, explosive, artificial silk, among others. It can be used to make soapless detergents, like what in Kenya we call Omo, um, be it Toes, be it any other soapless detergent. It can be used to do what called sulfonation of organic chemicals. If you want to add sulfur into some organic chemicals. Going on, it can be used in refining of petroleum, and even for making sulfate agricultural fertilizers like ammonium sulfate. Okay, the very last one there, it can also be used in what you call a plinking, yes. It can be used in what you call plinking of metals. Also what I have said, etching of metals. Now, some chemical properties, we can go through it very fast. Chemical properties of sulfuric 6 acid. Part 1, we are going to look at concentrated sulfuric acid. What exactly, how it behaves chemically. Now, it is a very good dehydrating agent. And by dehydrating agent means it can easily remove either the physically or chemically combined elements, that is H and O, in that ratio of 2:1 from compound. Actually, it forms water of its own from chemicals. It can remove the hydrogen and oxygen from the compounds. Like if I take sugar, then I add concentrated sulfuric acid. What exactly happened? The sugar, be it the brown sugar, white sugar, I'm going to observe some black specks, or it will be churned into black mass. And what exactly is happening? The acid, concentrated sulfuric acid, because it's a good dehydrating agent, it removes the hydrogen and oxygen elements from the sugar, and of course carbon will be formed. That's why it is appearing black. Carbon is black in color. Good, you can see the equation. Be it the white or the brown sugar, it will be converted into a black mass there. Good, going on, again as a dehydrating agent, if we add concentrated sulfuric acid into hydrated copper 2 sulfate, that is blue in color, it will change the color from blue to white. It will go white. Good, and for that, if I can explain what exactly is happening. The concentrated sulfuric acid removes the water, that is the water of crystallization, from the hydrated copper 2 sulfate, and then it becomes anhydrous, that is, it becomes anhydrous copper 2 sulfate, that is white. The chemical equation you can see there. Whether I'm working with copper 2 sulfate or I'm working with cobalt 2 chloride that is hydrated, the process will be the same. But for the cobalt 2 chloride, it will be converted from the pink color to blue color. Good. If we can move on, again as a dehydrating agent, concentrated sulfuric acid added to absolute ethanol, yes, at a temperature of about 170. Again, it will be dehydrated, and a colorless gas will be formed, that is ethene. So you can dehydrate ethanol to ethene, and of course water will be removed using concentrated sulfuric acid, and that is one way of preparing ethene. A dehydration process, again, methanoic acid and concentrated sulfuric acid. This one you can again convert it. You can convert methanoic acid to carbon 2 oxide. Yes, carbon 2 oxide. And remember, these are very poisonous gas. You cannot try this in an ordinary school laboratory. As you can see there, the chemical reaction. Some similar reactions is when you're having oxalic acid, or what we call ethanedioic acid. It can also be converted to carbon 4 oxide, carbon 2 oxide, and water by dehydration. If you want to remove carbon 4 oxide, you can pass that mixture through maybe lime water, and of course the gas carbon 4 oxide will be removed. Remember what we've said with this, it's a very poisonous, the gas CO, very poisonous. You don't try it. And these are good method for preparing carbon 2 oxide. Maybe a question that I did not give you back, we can go back to where we're talking about sugar. Yes, where we're dehydrating sugar. this is as a reaction also that should not be tried. The carbon particles here, they can fume, they can be suspended into the air, and when they get into the lungs, if you inhale them, they can block the alveoli, or rather it can interfere with the breathing system there. Otherwise, we proceed. We were talking about dehydration process, how sulfuric acid do dehydrate, and we are done with that. We can talk about it being a very good oxidizing agent. If it reacts with the metals, like metals that cannot easily react with the acid, like copper, it can easily be oxidized. Yeah, and itself is reduced to sulfur 4 oxide. And it can also react with some non-metals as well. And I've just said sulfur 4 oxide is produced. Something you need to know: how do I test for sulfur 4 oxide? We use a moist filter paper, or just a moist paper that is dipped in potassium dichromate. Remember, that is orange, and it changes to green. Don't forget that is how you test the presence of sulfur 4 oxide. Use the dichromate paper, or rather you can use the dichromate solution. Yes, you can use dichromate solution or the dichromate. As an oxidizing agent, it can react with the metals, or this one I've just said. When it reacts with the metals, concentrated sulfuric acid, remember this should be liquid. This should be liquid. Yes, it forms the salt, sulfur 4 oxide, and water. Be it copper, reacting with copper, reacting with zinc, reacting with iron, you can see the solutions formed there. Yes, that one you can see. Next, as an oxidizing agent, again, reaction with non-metals. You can see the chemical reactions, like when it reacts with carbon, it forms a mixture of carbon 4 oxide, then sulfur 4 oxide, and water. It can also react with sulfur, and it forms sulfur 4 oxide and water. Good. Sulfuric acid, when it is concentrated, it has a very good displacing power to less volatile acids from their salts. Remember, itself it's less volatile. Actually, it displaces more volatile mineral acid. Like if I have nitrate, potassium nitrate with sulfuric acid, you can see it forms potassium hydrogen sulfate. Not potassium sulfate, but potassium hydrogen sulfate, and fumes of nitric acid there. So that process can easily be used to prepare nitric 5 acid. If it is with the chlorides, like potassium chloride, sodium chloride, again, concentrated sulfuric acid can displace the HCl gas from these chlorides, because itself is less volatile. So it displaces the more volatile acids from the salts. Chemical properties of sulfuric acid when it is dilute. Okay, dissociation in water. If I add acid to water, remember that's what we said, you add acid to water, it breaks down to form as hydrogen ions and sulfate ions. This is a complete dissociation. So this is a strong acid with a pH value 1 to 3. Chemical reactions, as you can see there, that is a complete dissociation, as you can see, with the 2H plus and a sulfate ion there. Chemical reactions, reacting with metals. As usual, the general reaction. A metal reacts with acid to form a salt and hydrogen gas. Like some chemical reaction, I've just selected some few for you to see there. Magnesium reacting with sulfuric acid, you get the sulfate, magnesium sulfate and hydrogen gas. Then zinc sulfate and hydrogen gas. Iron sulfate and hydrogen gas. Note some few very interesting processes that you should know. Copper does not react with sulfuric acid. Neither does it react with any other dilute acid. Copper is below hydrogen in the reactivity series. Therefore, it cannot easily displace hydrogens ions from the solution. So that one you should know. Then another very interesting reaction that you should know is when you try to react calcium, barium, lead with this sulfuric acid, the reaction stops after a short time. And this is not the only reaction that stops. Any reaction that leads to a formation of insoluble substance, be it salt or hydroxide, that reaction cannot proceed for a long time. What exactly happens is that the salt formed, the insoluble salt, covers the metal and stops or further contact with the acid. Potassium and sodium and maybe lithium, they react explosively with this acid, so that's a reaction never to be tried. We go on with the carbonate and hydrogen carbonates. As usual, acid react with the carbonate, you get salt, water, and carbon dioxide. Like some few examples I've selected for you there, you can observe what exactly happening. For my student, kindly try to practice how to write these chemical equations, because the reaction will keep on repeating itself. The reactions will repeat themselves and they will always be the same, and they resemble. Like you can see in the first column, all these are salts, then the second water, and then the last one carbon dioxide. Actually, when an acid comes in contact with a carbonate, there must be fumes of a colorless gas, or fizzing, or effervescence of a colorless gas, carbon dioxide. If we can proceed, a chemical reaction, again, reaction with the bases. An acid reacting with a base, you get acid, you get a salt and water. And a base can either be a metal oxide, it can also be a soluble, it can also be a hydroxide. A soluble base, it's basically called an alkali. We have just 2 or 3 chemical reactions there. Yeah, 3 of them, 4. Yeah. You can see a base, a metal oxide, reacting with a sulfuric acid, you get the sulfate, salt, and water. If we proceed to the next reaction of the acid sulfuric with some hydroxides, you can see what exactly happened. Again, it's a salt and water. Salt and water there. Good. I think we're done with the part that is discussing sulfuric acid, contact process, and there's some chemical properties and physical properties. Now we can look at some of the questions. This one, I may not give the answers, but they are good. One thing you should notice is that these questions will keep on repeating themselves. It can be a short structured question. You can also have them as what we call the long structured question. Like if you consider this one, that is a long structured question. You are supposed to study the flowchart. Yes, the student is to study the flowchart very carefully, then goes ahead to answer the questions. So for instance, you can look at this. Look at the question as it is. Yep. Yeah, let me go back here. Yep. Look at that question. The flowchart, you have solid A, air, burned, sulfur dioxide and air comes out, purified into the heat exchanger, into the catalytic chamber, back to the catalytic chamber, cooled, then absorption tower and the dilution tower. So the student, for instance, is to name 2 possible identities of A, then name the impurities that are removed, why it is necessary to remove the impurities, write down the equation in the converter, 2 possible catalysts, okay, then the function of the heat exchanger, why sulfur 6 oxide is not dissolved in water directly, name 2 pollutants in this process, and then how the pollution can be prevented, and give 1 use of sulfuric acid. You can see like that one. It's a good summary of contact process and some of the questions there. You can have like this one, and look at this one. Again, this is contact process. A contact process question there. Yes, contact process question. As you can see, a very nice one. You start from sulfur again and oxygen, step 1, into G, that chamber G, going all the way to a dust precipitator. Air gets in there, into a drying tower. Then you have the heat exchanger, converter again, all the way to this is a dilution, the what we call the the absorption tower, and then X, the dilution there. Sulfuric acid comes out. So you name the chamber XYZ. You also give 3 conditions that are in the converter. Conditions talk about the temperature, pressure, and the catalyst. Why the gases should be passed through the precipitator and drying tower. Yes, that is tower. You can answer that. Then the chamber Y, the use of chamber Y should be passed through the chamber Y. Then write the equation for step 2, step 3, and step 4. You can see step 1 in the roster. Step 2 inside the converter. Step 3, this one is in, or step 4, that is how oleum or sulfur oxide is, that is oleum. How oleum is converted to sulfuric acid. That one is good. And then you can have the very last question there, like this one. This one mainly, it's not so much of the sulfuric, but it's a good question from what we call sulfur and its compounds. So look at the question, the flow chart. You study the flow chart first, then attempt these questions. That is like the question number 3. Going on maybe to question number 4, you can also have the short structured question like this one. That's a short structured question. So go through it. Yes, like you're given the density of sulfuric acid when it is concentrated, then you calculate the molality. And actually we do assume, and we do say, the concentrated sulfuric acid is 98% pure. So you can say that. Kindly attempt the question, attempt that one. Yes, question number 5, you can see that one. Oleum is the intermediate product in the industrial manufacture of sulfuric acid. How oleum can be converted to sulfuric acid. Give one use. I have said this question will keep on repeating themselves. In the manufacture of sulfuric acid, sulfur oxide is oxidized to sulfur 6. Name the catalyst, write the equation. Yep, even the other one, explain using equation how dilute sulfuric acid can be obtained. Good. Question 7, concentrated sulfuric acid, is it a weak acid or a strong acid? Then you explain. As simple as that. Question number 8, a bit long there, a lot of literature. When a mixture of concentrated sulfuric 6 acid and copper heated strongly, a colorless gas will be obtained and a solid mixture there. White and black solids are formed. Okay, when this solid is mixed and treated with the distilled water and filtered, a blue solution. Following that, then you explain the observations that are made there. 2 reasons for why sulfuric 6 acid is not dissolved in water directly. That one we said even in the discussion. 1 use of sulfuric 6 acid. Question 10. In an attempt to prepare sulfur oxide, dilute sulfuric acid is reacted with barium carbonate. The yield of the sulfur oxide was found to be negligible. Explain. Whether they twist the question or not, be wise, be a smart student. Okay, like that one. Yes. If you can look at this, remember this process here is reversible. So here there must be the reversible sign. So these are reversible process. Then you name the catalyst for this. Okay. Then state and explain if for this reversible reaction that is at equilibrium, yes, how can you affect the yield of sulfur 6 oxide? If you increase pressure, if you use a catalyst, then the ordinary question, why should we use water to dilute? Why can't we use water to dilute sulfur 6 oxide? Otherwise, this question will keep repeating themselves. And the question on sulfuric acid can also be tied to other topics. Like you can see this one is tied to the rates of reaction, equilibrium. So my student, be wise and revise broadly. Otherwise, thank you for watching. Kindly subscribe to this channel. Like my content there. Do some comment, share with others, recommend. Because all I'm doing is for the benefit of the student. Otherwise, thank you, and thank you once again. This is Dr.